I will be explaining the topic corrosion. As you all know, corrosion is the process of disintegration or deterioration of metals or alloys. It can happen by chemical or electrochemical reaction with the environment. That means it is the destruction of metals or alloys by reacting with the environment. Most of the metals except the noble metals like gold and platinum exist in nature as their compounds. That means they exist as metal oxides, metal sulfates, metal carbonates, etc. The metal is extracted from its ore after a series of metallurgical processes. That means the pure metal will always be at a higher energy state than its ore. Every system in nature wants to be in its lower energy state. So metals also want to be in their lower energy state. So there is a natural tendency to revert back to its thermodynamically stable state. That means the pure metal will be getting converted into its stable state, that means in the compound form. The metal has the tendency to revert back into its compound form. And that is the basic reason behind metallic corrosion. Why is it much important to study metallic corrosion? Because the economic loss due to corrosion is very high. It is estimated that the average loss of corrosion in India is approximately 200 to 250 crores per year. Extensive research works are going on to find out the methods to control corrosion. So it's very much important to study corrosion. Now let's discuss the theories of corrosion. Corrosion reactions are mainly of two types. One is dry or chemical corrosion. The second one is wet or electrochemical corrosion. Dry chemical corrosion is classified into three. First one is oxidation corrosion. High temperature corrosion of iron is an example for oxidation corrosion. The second one is corrosion by other gases. Oxidation by gases like chlorine will come under this category. Then the third one is liquid metal corrosion. That is the dissolution of a metal in liquid metals like sodium or mercury. If the metal is dissolved in a liquid metal like mercury, it will result in the formation of amalgams. Then the second is wet or electrochemical corrosion. It is classified into two: hydrogen evolution type corrosion and oxygen absorption corrosion. In the syllabus, you have to study wet or electrochemical corrosion. So in the coming session, I will be focusing only on wet or electrochemical corrosion. Now let's have a look at the mechanism of wet or electrochemical corrosion. Electrochemical corrosion occurs by the formation of galvanic cell under wet condition. That means there should be a conducting medium. Wet condition means there should be a conducting medium, and in presence of that conducting medium, a galvanic cell is formed. Whenever a metal is undergoing corrosion, the metal is oxidizing. It is getting oxidized. A pure metal will be in an oxidation state of 0, and whenever it is converted into its compound, the oxidation state will increase. That means the metal is getting oxidized. So whenever a metal is undergoing corrosion, that means it is undergoing oxidation process. Oxidation occurs at the anode and will generate the metallic ion. Since the metal is acting as the anode, the metallic ions will be formed at the anode. The corrosion occurs at the anode. When metal is getting oxidized, electrons are formed in the anode, which move through the conducting medium and is known as the corrosion current. When metal is getting oxidized, metallic ions and electrons will be produced, and that electrons will move from the anode to the cathode, and that is known as the corrosion current. Reduction takes place at cathode. The environment which is very close to the surface of the metal will be acting as the cathode, and reduction takes place there. The dissolved constituents like O2 or H plus will be getting converted to non-metallic ions like OH minus or O2 minus. Metallic ions and non-metallic ions. When metallic ions and non-metallic ions are formed, they will diffuse towards each other, to the conducting media and will result in the formation of corrosion product. The corrosion product is formed somewhere in between anode and cathodic areas. So the diffusion of metallic and non-metallic ions will happen through the conducting media, and that will result in the formation of corrosion product in between the anodic and cathodic area. Separate anodic and cathodic areas are formed due to the deposition of corrosion product between which current flows through the conducting media. Once a corrosion product is formed, you will have a separate anodic and cathodic area through which the current flows. So this is the general mechanism. So you have to remember the metal is acting as the anode and metallic ions will be produced. The element which is very near to the surface of the metal will be acting as the cathode. Non-metallic ions will be produced there. After the production of metallic and non-metallic ions, they will diffuse to each other and you will get the corrosion product somewhere in between the anode and cathode. So once the corrosion product is formed, separate anodic and cathodic areas will be set up and current will be flowing through the conducting media. This is a general mechanism for electrochemical corrosion. So now we have to study the hydrogen evolution corrosion and oxygen absorption corrosion in detail. So both these type of corrosion, hydrogen evolution and oxygen absorption corrosion, can occur in acidic as well as in alkaline medium. You have to study the hydrogen evolution corrosion in acidic medium as well as in alkaline medium. So first have a look at the hydrogen evolution corrosion in acidic medium. So from the name itself you will get some idea. Since this is hydrogen evolution, there will be a evolution of hydrogen gas. H2 gas will be formed and the reaction will be happening in acidic medium. Since the oxidation process is happening by hydrogen evolution, it happens when there is insufficient amount of oxygen. It happens when a metal is in contact with acid solution and also in the absence of sufficient oxygen concentration. When oxygen concentration is low, corrosion occurs by hydrogen evolution. We have studied that oxidation means evolution of hydrogen or addition of oxygen. Okay, so if there is no sufficient amount of oxygen, corrosion occurs by hydrogen evolution mechanism in acid medium. So generally metals having negative reduction potential like iron, zinc, aluminium undergo corrosion by this mechanism. You know that the potential of hydrogen electrode is 0 and any metals which is coming under that value, that means negative value, any metal which is having a value below 0 will be acting as the anode. A metal with higher reduction potential will be acting as the cathode and a metal with or a species with higher reduction potential will be acting as the cathode and a species with lower reduction potential will be acting as the anode. Okay, so you have a metal which is having negative reduction potential will undergo corrosion by this method. The example is iron, zinc, aluminium, etc. You know the potential of hydrogen in acid medium, it is 0. So anything which comes below that value, any metal which is coming below 0 will be undergoing corrosion by this mechanism. So let's take the example of iron. So this is a schematic representation. So iron, the reduction potential is minus 0.44. Iron is getting converted to Fe3 plus. The reduction potential is minus 0.44. And this is the potential of hydrogen. Hydrogen is 0. If you look at the potential, it's very clear that iron will be acting as the anode. And this is the reaction that is happening there. Hydrogen will be acting as the cathode and hydrogen evolution will occur. And also you can calculate the E0 of this cell. You have to just add this reaction at the anode and cathode, then you will get the net cell reaction and you can find out the E0 cell also. So get the E0 cell as 0.44 volt. So any metal which is having negative reduction potential can undergo corrosion by this mechanism. So now let's have a look at the hydrogen evolution corrosion in alkaline medium. So we have studied the dependence of electrode potential of hydrogen with pH. So when the pH changes, the hydrogen electrode potential changes. The equation is E of hydrogen electrode is equal to minus 0.0591 into pH. In alkaline medium, you can consider the pH as 14. So if you remember the value, the electrode potential in alkaline medium is minus 0.828 volt. So any metal which is having electrode potential lower than this value can undergo corrosion by this mechanism, by hydrogen evolution in alkaline medium. So hydrogen electrode potential in alkaline medium is minus 0.828. Any metal which is having a potential lower than this value can undergo corrosion by this mechanism. Okay. So let's consider the case of iron. Iron has the potential of minus 0.44. If you look at both these potential, hydrogen electrode potential in alkaline medium and iron potential, it's very clear that the potential of iron is higher. So that means the iron will not be acting as the anode and won't be acting as the anode. So iron is not getting corroded by this mechanism. The potential of iron is higher than that of hydrogen electrode potential in alkaline medium. Iron won't be acting as the anode and corrosion is not happening by hydrogen evolution mechanism in alkaline medium for iron. Let's have a look at the case of aluminium. So this is the reduction potential of aluminium. It's minus 1.66, which is lower than this value, minus 0.828. So if you compare these two values, aluminium will be acting as the anode and it will be getting corroded. So this is the reaction for hydrogen electrode alkaline condition. So it's the same reaction for hydrogen electrode. So in order to specify that it is at alkaline condition, we have added 2 OH minus to both the sides. We have added OH minus to both the sides and you will arrive at this equation. This is the same equation. In order to show that it is done under alkaline condition, 2 OH minuses are added. And you compare these two values of aluminium and hydrogen at alkaline medium, it's very clear that aluminium will be acting as the anode. One with lower reduction potential will be acting as the anode and it will be undergoing corrosion by hydrogen evolution in alkaline medium. So now let's discuss oxygen absorption corrosion. So here also we have to study at two different conditions in acidic medium as well as in alkaline medium. It occurs when the metal is in contact with water having dissolved oxygen in acidic or even in neutral medium. So this process can occur even in neutral medium when it is in contact with sufficient amount of oxygen and when there is a conducting medium. So let's again take the example for iron. So this is the reduction potential of iron minus 0.44. And if you consider the reduction potential of oxygen electrode, it is plus 1.23. So iron has a potential of minus 0.44 and oxygen electrode plus 1.23. So from this potential value, it is clear that iron has a lower potential and it will be acting as the anode. That means it is undergoing corrosion. Whenever the potential is low, it is acting as the anode and it is undergoing corrosion. Anode means oxidation happen and iron will be getting converted to Fe2+. So you the overall reaction, you can just add these two reactions at the anode and cathode and you can write the net reaction and you can also find out the E0 cell. E0 cell is 1.67. So you remember the hydrogen absorption corrosion and acid medium, the value for E cell was 1.44 and in the case of oxygen absorption corrosion and acid medium, it is 1.67. So in acid medium, there is a peculiar thing happening. Oxygen absorption corrosion and acid medium, iron, there's a peculiarity for iron corrosion in acid medium, oxygen absorption mechanism. So once the Fe2+ ion is produced, it further get oxidized to Fe3 plus. Once Fe2 plus is produced by this mechanism, it readily get oxidized to Fe3 plus. If you look at the electrode potential of Fe3 plus Fe2 plus system, its value is 0.77 volt. The value for the conversion of Fe2 plus to Fe3 plus is 0.77 volt. So that means it will be getting, once the Fe2 plus is formed, that will be again getting oxidized to Fe3 plus. If you remember the value of oxygen electrode, it is 1.23, which is greater than 0.77. That means Fe2 plus will be getting oxidized to Fe3 plus. Fe3 plus produced here forms insoluble precipitate of FeOH thrice, which is known as the yellow rust. Once Fe3 plus is produced, it will combine with OH minus and you will get FeOH thrice, and it is called the yellow rust. If the amount of moisture is less, black rust is formed. Black rust, otherwise known as magnetite, which has the formula FeO.Fe2O3, is formed when there is insufficient amount of moisture or amount of moisture is less. So this is the common corrosion that is happening to iron. So what's the peculiarity of oxygen absorption corrosion in acid medium for iron? So generally Fe2 plus will be formed. Once this Fe2 plus is formed, it will be readily getting converted into Fe3 plus because the potential of oxygen electrode is higher when compared to Fe3 plus Fe2 plus system. If you compare the oxygen electrode potential, it is 1.23. So oxygen electrode will be acting as the cathode and Fe2 plus will be acting as the anode. Fe2 plus will be getting oxidized to Fe3 plus. This corrosion has a peculiar name and it is known as pitting corrosion. This formation leads to intense localized corrosion called pitting corrosion. So once you get the yellow rust or black rust, pitting corrosion will occur. Pitting corrosion means what? Where the rust is adhered, the area just below that one will corrode rapidly and pits will be formed there, and that is known as the pitting corrosion. Okay, once FeOH thrice or yellow rust or black rust is formed, that area will be acting as the new anode. The metal just beneath that rust will now undergo corrosion fastly and pits will be formed. So the precipitate adhered area which is not in contact with oxygen is now the new anodic area, and the oxygen exposed area will be acting as the cathodic area. That means the environment which is near to the surface will be acting as the cathodic area. So this schematic representation. So let's again look at the oxygen absorption corrosion and acidic media for iron. So the first thing is common as that of hydrogen evolution corrosion. Have to look at the reduction potential, and it's very clear that iron will be undergoing oxidation and will be acting as the anode. Once Fe2 plus is formed, it will be getting readily converted to Fe3 plus, since the reduction potential of Fe2 plus to Fe3 plus is low when compared to oxygen potential. Okay, so you will get yellow rust and black rust depending upon the amount of moisture, and that rust formation will lead to intense localized corrosion known as pitting corrosion. The precipitate adhered area is now acting as the anode and the oxygen exposed area is acting as the cathode. So this is very important. Corrosion of iron as a medium in presence of sufficient oxygen. Now let's move to the last mechanism, oxygen absorption corrosion in alkaline medium. It occurs when metals are in contact with water having dissolved oxygen in alkaline environment. So let me consider the example of iron. So this is the equation for iron. Let's consider the equation for oxygen electrode at alkaline medium. So in alkaline medium, you have to consider the pH as 14 and the potential is 0.40. In acidic medium, it was plus 1.23 and in alkaline medium, it was 0.40 volt. So if you look at these two values, it's also clear that the potential of iron is low and that will be acting as the anode. That means it will undergo corrosion. We can write the net cell reaction and you can also find the E0 value. E0 is 0.84 volt. So here there is no chance of beating corrosion. Here if you look at the potential for changing from Fe2 plus to Fe3 plus, it is 0.77. And consider this value, if you compare these two values, it is clear that the value for iron is higher. So it will be acting as the cathode. That means Fe2 plus won't be acting as the anode. So the formation of Fe3 plus is not possible. Okay, so pitting corrosion is not occurring in presence of alkaline medium. Corrosion only happens by oxygen absorption and acidic medium, whereas oxygen absorption in alkaline medium does not result in pitting corrosion. So let's compare the corrosion of iron. You have studied three different mechanisms. One is hydrogen evolution corrosion in acidic medium, oxygen absorption corrosion in acidic as well as alkaline medium. Iron won't undergo corrosion by hydrogen evolution in alkaline medium. So there are three ways where iron can undergo corrosion. Okay, so corrosion of iron is rapid under which condition and why? I have a question for you. Corrosion of iron is rapid under which condition? So iron can undergo corrosion under three conditions. So which condition is more rapid and what is the reason? You can give me the answer in the online discussion class. So please think about this question. Corrosion of iron is rapid under which condition and why?